In this exercise, we have to use Cramer's rule to solve the system of linear equations, three equations in three unknowns, x, y, and z. Just want you to note that we do this almost without saying, but you have to at least mentally imagine there's a 1 here and a 1 here, and also that there's a 0y, and what else? And also here we have a 0y. I usually don't mention it, but once in a while, the ones and the zeros you have to watch out for. And Cramer's rule says that each of x, y, and z is a fraction where the denominator is the determinant of the coefficient matrix or restricted matrix. And here it is. We just take the coefficients from here: 1, 0, 1, 4, 0, 4, 1, 8, sorry, and then 2, 0, 3. And the same thing here and here. I've just copied it. Now, on the numerator, we have in each case something similar to the denominator, except that each time we replace a different column with these numbers, 321, 8. Here we replace the first column, and we get this. And I used the coloring in blue just so you can see more clearly what's happening, and everything else is the same. And similarly for y, the same except for the middle column, which are these. And the numerator for z, also same pattern. Okay, now this denominator we only have to compute once. The easiest is to expand along the middle column because everything's 0 except for this entry. So this is the only entry that counts. I take the minor by removing this row also. So I've got 1, 1, 2, 3 is the minor. Its determinant is 3 minus 2 is 1. Then I have to multiply by this 1, so it's still 1. And then there's a matter of the sign, the checkerboard, remember? Plus, minus, plus. So altogether, this comes out to 1. And similarly, here and here, it's the same determinant. And now, here we can also expand along the middle column. And in this case, we get also a plus times 1. And the minor is 3 times 3 minus 8 times 1.